Data integration is about connecting the dots, matching data elements that are closely related in the real world. With the amount of data sources that are being used together in different applications, there is no deterministic way of deciding which element matches which. Therefore, we use models of uncertainty together with advanced machine learning to create an effective way of connecting data elements together.
My research revolves around theoretical and algorithmic foundations of deep learning, also known as neural networks. It adopts a highly mathematical approach, but in addition, there are algorithmic contributions that involve extensive empirical evaluations.
Data exchange in the internet is mostly encrypted, which poses a problem for network operators that try to prioritize data that is more sensitive to delay. Our research aims to identify from the stream of packets in the internet what is the application that is actually running in the pipe.
Information theory has many applications in communication and in signal processing, but there are also interesting applications in machine learning and in artificial intelligence. By using the information theoretic tools, we are able to show how to build universal predictors that describe the complicated models like deep neural networks or transformers.
In the last few years, there's been a revolution in artificial intelligence, or AI, now building on deep learning or deep models. My research focuses on solving the two main bottlenecks. First, we're trying to make training and using those models much cheaper. Also, we try to understand those models, try to figure out what makes them tick and how they work.
My research provides foundational understanding of deep learning. This is a major scientific challenge due to the many new aspects that deep learning has compared to conventional machine learning. My research includes mathematical theory and also empirical foundations based on extensive experiments directly on deep learning.
Humans were traditionally considered the holy grail of data integration against which all algorithmic solutions were evaluated. In our research, we realized that both humans and algorithms have different biases, and therefore we have developed an algorithm, one algorithm to rule them all, that basically looks at the decision-making of humans and algorithms and decides which one to grab for an effective data integration solution.
We devised a clever way to transform flow data into a picture. We call it a flow pick. Using these pictures, we can use standard and strong picture classification tools to achieve very high accuracy of our flows. The two main applications are traffic engineering, the ability to prioritize one type of traffic over the other, and cybersecurity, where I can identify malicious traffic.
Having the computational resources of the center and the resources of the companies that are affiliated with the center, together with the great talent of students and the collaboration with other faculty, makes Tel Aviv University the perfect place for conducting the type of research I'm doing.
Tel Aviv University is exceptionally supportive of cross-disciplinary collaborations, and this encourages and helps researchers form different collaborations that involve people from various backgrounds. Oftentimes it leads to tackling problems from new directions, and that leads to new solutions.
For this type of research, I need two ingredients: strong servers and excellent students. Luckily for me, here at the Technion, I have the best servers for the cause and the best students Israel has to offer.
The empirical foundations research in my group is based on extensive experiments on deep learning, for which we use the great GPU cluster that we have in Ben Gurion University.
Developing better models and understanding what's going on in AI will enable us to have more control on those technologies and will enable us to make them better. And this will lead to a huge benefit to the entire society.
Consider the world of Gen AI, where data is being generated by artificial intelligence. It takes all the data integration tools that we have to be able to identify correct from incorrect data. And this is what we aim for as our next goal.